Today's daily code problem of the day is max chunks to make sorted, number 769. For this problem, we are given an integer array called ARR, where our length of n represents the permutations of the integers in the range from 0 to n minus 1. We can split our array into some number of chunks, or partitions, and individually sort each chunk. After concatenating them, the result should be equal to our sorted array. We want to return the longest number of chunks, or the largest number of chunks that we can make into a sorted array. So, for this problem, if we look down here at example 1, we have a integer array where each number is unique, meaning that each number is in a way that can be sorted. So from 0 to 4, from 0 to 5, no numbers are skipped. And we want to find a way that we can break this array up into chunks, where if we sort those chunks and then put them together, they will create a sorted array. If we look here at example 1, we can see that there is a pattern. So 4, 3, 2, 1, 0, it's going to have an output of one chunk, because if we look down here, splitting it into two or more like this, we'll end up with bigger numbers, or our bigger numbers coming before our smaller numbers, making it unsorted. So when a bigger number comes before a smaller number, we're going to need to have all of that in one group, so that way we could sort the numbers in the positions that they should be in. So, taking this all into consideration, how are we going to approach this problem? We can identify a pattern. Again, if we look at example 2, we can see that pattern in action more than in example 1. But let's take, for instance, if we keep a local maximum. So let's keep track of our max value as we traverse the array. Starting at position 0, our max is 1. Moving over to position 1, our max is still 1. But we are going to simply check if our max is equal to its position. So if I is equal to 1 and our max is equal to 1, we have identified a chunk that can be sorted. So this chunk can now be sorted. We'll have 0 and then 1. Moving on, we look at 2. 2 is our new max. Let's update our max. 2 is the max. Let's see. Maybe I should just use the eraser. 2 is our new max, and it just so happens to be at position 2 as well. So with the max equal to 2, at position 2, we have identified a new chunk. 2. Same thing for 3, and then same thing for 4. We can see the same pattern up here for example 1. 4 is our maximum all the way until the end, and that position just so happens to be, if we count, this is 0, 1, 2, 3, and 4. So this is going to be one big group, as our maximum equals its position in the array. So taking that pattern, we can implement that into our code. So we're going to traverse our array from left to right, track the maximum value we've seen so far, and in each index of I, we're going to see if the index is equal to our max, and if it is, that can be a chunk. So let's first define an integer called max, that'll start at 0, and an integer called chunks that will simply track how many chunks that we have. Now all we have to do is traverse our array from left to right, so for each integer, as it traverses our array, I will increment, and all we have to do is update our max. So max is always going to be equal to the math function dot max, and we're going to pass it the current max value and ARR of I, and we're simply going to check if our max value is equal to I, then we can increase chunks. Because we're never storing anything in arrays, because we're never combining or calculating anything, we never even need to update what our max is besides this simple check. So for each integer in the array, we'll see if we can update our max. If we can't, we'll check if the max value is equal to the I value, and if it is, we'll update chunks to add 1. And that's all we have to do. So if we run this, pass our test cases, and if we submit it, it passes all solutions. Thank you, and follow for more daily LeetCode solutions.